Alright, today is Thursday, March 30th, and I'm going to go through today's lesson. So today's lesson starts off with our warm-up, and we have 0.9 raised to the 1,000th power. So I'm just trying to make sure that everybody knows when this pops up on your calculator screen what it actually means. So when you see this e to the negative 46, that's actually scientific notation. So I'm going to round my decimal to be 1.75 times e, and it says to the negative 46. So if it's to the negative 46, that means I'm going to take this decimal, and because it's negative, I'm going to move 46 places to the left. So this would be one place, and then I would have 45 more places that would be blank. So all those little blank spaces would be 0. So the actual answer would be 0.045 times 175. Okay, let's try the next one. So that's going to be a really small number. The next one, we have 1.1 raised to the 1,000. And this time, I get 2.47, and I got an e to the positive 41. So I'm going to go write that as 2.47 times 10, the 10 times 10 scientific notation, to the positive 41. Because it's a positive, it's going to move to the right 41 places. So that's 1, 2, and then it would be followed by 39 more zeros. So this would be a really big number. So the first one is a really small number. It's got 45 zeros in front of the 175. And the second number is a really large number. It's 247 with 39 zeros behind it. So today in class, if you missed, we talked about what's called a limit of an infinite sequence. So let's talk about what these words mean. Limits mean where something ends at, and something infinite meaning it never ends. So what we're really trying to do is figure out what am I approaching, or what am I getting close to in general. So in class, we first started off with something like this. And I said, okay, let's see if we can find a pattern. 1/2, 1/4, 1/8, 1/16. You'll notice that each one of these denominators is getting multiplied by 2. So the next one would be 1 over 32, 1 over 64, or we could just write it as a function as 1/2 raised to the x power. And if I were to go look at this in my calculator and start my table at 0, I would see that 1/2 raised to the 0 is 1, because anything to the 0 power is 1. And 1/2 raised to the first is a half. 1/2 is really 0.5, and 1/4 is really 0.25, and 1/8 is really 0.125. And if I held my finger down on my calculator, I would see that all my y answers are getting smaller and smaller and smaller. Look at all those e to the negative numbers. And they're getting smaller and smaller and smaller. And I could hold this finger down forever, and you're going to see this e to the negative button getting bigger and bigger and bigger, which means that many more zeros out front. So what we're going to say is that the limit as n approaches infinity of 1/2 raised to the n. So this means the bigger this number gets, what is this 1/2 getting closer and closer and closer to? Well, it's getting smaller and smaller and smaller, so it's getting closer and closer to 0. So this is our first little snippet of an infinite limit. Let's go look at another one. On this next one, we've got 1.01 raised to the n power. So I'm going to type that in. I'm going to start my table at 0 again. Oops. Second window. Start at 0. And we see that 1.01 raised to the 0 is 1, and then we get the 1.01, the 1.021. And this time, as I hold my finger down, my numbers are actually getting bigger. I have 1.27, 1.37, 1.48, now I'm 1.5. I'm just going to keep holding my finger down for a little bit. And we'll notice those y values, oh, now I'm in the 2s, keep getting bigger and bigger and bigger. In fact, I can hold my finger down for a really long time. I can hold it down forever, which would be to infinity, And what do I see keeps happening? My numbers keep growing. They keep getting bigger and bigger and bigger. Well, they're going to grow forever. If they're going to grow forever, we're saying that our limit's approaching forever. Well, in our class, we're going to leave the limit to be infinity, but really the limit does not exist because you can never really approach something that you can't get to. You can never get to infinity because it goes on forever. So we're going to say the limit does not exist. So we have two things that we figured out so far. We figured out that if we have a number that's less than 1, but bigger than 0, there's no negatives. So all your decimals and fractions that are less than 1, as n gets closer to infinity, and I'm raising it to the n power, your limit's going to get closer and closer to 0. We also said, in one of our examples, if your number is bigger than 1, so 1.01, 1.5, 2 point something, anything bigger than 1, raised to the n power, we're going to say that limit approaches infinity. But we also know we could write it does not exist because you can't really approach something that you can never get to. The next thing we talked about in class is my friend Bobo Botten. And Bobo Botten gets really, really hungry. And when he gets really, really hungry, he eats DC. And this is just a way for us to memorize. It's just a mnemonic device for us to memorize some limits when we're doing rational functions. So here's what it stands for. Bobo means if the exponent is bigger on the bottom, the limit will approach 0. Botten, if the exponent is bigger on the top, then it's going to approach infinity. Eats DC, if the exponents are the same, we're going to divide the coefficients. And then we did 3 quick examples. So this is a rational function. We have a fraction. I've got n's on top and I've got n's on bottom. I'm going to circle the biggest exponent term on the top and the biggest exponent term on the bottom. And then I'm going to ask myself, what's bigger, 2 or 3? 3 is bigger. So bigger on bottom equals 0. Bigger on bottom equals 0. Second example. Again, it's a rational function. So I'm going to circle the exponent that's the biggest on the top and the biggest on the bottom. So I have 3n squared and 1n to the first. I'm just going to look at the exponents. What's bigger, 2 or 1? 2. So if it's bigger on top, we're going to say infinity. Third example. Rational function. N's on top, n's on bottom. I circle the biggest exponent on the top and the biggest exponent on the bottom. Is it bigger on top or bigger on bottom? Oh, this time it's neither. It's exactly the same. When your exponents are the same, we're going to divide the coefficients. So 2 divided by 8 is 1/4, or sometimes we'll see 0.25. So after we went over our special cases, we had if it was less than 1 and raised to a power. If it's less than 1 and raised to a power, we approach infinity. If it's bigger than 1 and raised to a power, it's going to approach infinity or does not exist. If we have rational expressions where we have n's on top and n's on bottom, we look at the exponents. If it's bigger on the bottom, it's 0. Bigger on top, it's infinite. If they're exactly the same, we divide the coefficients. So these are just some tricks so that when we do limits, it'll make it a little bit easier. And we did a couple more examples. So right here on my example 1 right here, I've got a number less than 1 raised to a power. Less than 1 raised to the power as n approaches infinity is 0. On this one, I've got a rational. We've got n's on top, n's on bottom. So I circle them. Bigger on top, so I write bigger on top. Ooh, that's my Botten. Infinite. Bobo Botten eats DC. This one isn't any of the rules I talked about. I just have to think about it. So as n gets bigger and bigger and bigger, what's happening to this part of the expression? Well, 1 to any power is just 1. So no matter what my n is, this is going to be 1. But as I divide 1 by 2, 1 by 3, 1 by 4, 1 by 5, 1 by 6, 1 by 7, and on and on and on, this whole thing right here is getting closer and closer to 0. So if this is getting closer and closer to 0, and I add 1 to it, the whole thing just equals 1 plus 0, which is 1. Example 4. We've got a rational expression. So this is when I do my Bobo Botan eats DC. It's not bigger on top. It's not bigger on bottom. They're exactly the same. So I divide my coefficients, and I have 1 over 2, 4.5. Example number 5. This isn't any of the rules. This is one of those ones I have to think about. So as 1 gets divided by n, and n gets bigger, 1 divided by 2, 1 divided by 3, 1 divided by 4, this whole thing is getting closer and closer to 0. So I want to know, what is the sign of 0? Well, I have to think about my old friend, the unit circle. And I'm looking at sign of 0. Sign of 0 is right here in this corner. That ordered pair is 1, 0, and sign means the y value, so the answer is 0. And the last example that I did in class, we have another rational here. So I'm going to circle the biggest exponent on the top and the biggest exponent on the bottom. It is not bigger on top. It happens to be bigger on bottom. This is my Bobo, so it equals 0. Our assignment is worksheet 13-4. We're going to get rid of 19, 21, 23, and 26. Remember, all your homework is due Monday, April the 3rd. Okay, bring questions to class if you have any.